take a look at today's lesson. Today we will identify the domain and intercepts of a rational function, and we will be able to explain how to find the domain and intercepts of rational functions. So let's take a look at today's lesson. Let's take a look at today's do now. For which value of x is the expression undefined? Number 1. Number 2, using the graph, identify the x-intercept, the y-intercept of the rational function. So pause this video and try these out on your own. All right, so for number 1, an expression is undefined when the denominator is equal to 0. So I set my denominator equal to 0 and solve for x, giving me 7/6. For number 2, the x-intercept is the point on the x-axis, which is -5, 0. And the y-intercept is the point that is on the y-axis, which is 0, -2.5. So let's take a look at today's thinking. How do we find the intercepts of a rational function? So a rational function, the definition, a rational function is a function that looks like a fraction and has a variable in the denominator. Steps for finding the domain of a rational function. Set the denominator not equal to 0 and exclude these values. Represent the domain using interval notation, set notation, or inequality notation. Steps for finding the y-intercept of a rational function. We set x equal to 0 and solve for y, because the y-intercept is always a point on the y-axis, which means we would have a point 0, some number. To solve for the x-intercepts of a rational function, we're going to set y equal to 0 and solve for x. Why? Because the x-intercept is always on the x-axis, which means it's always going to be a number, 0, which means y is going to be set equal to 0. So let's take a look at our first example. We have find the domain of the function f of x, which is equal to x plus 3/6x minus 7. We want to represent our domain using interval notation, using set notation, and using inequality notation. So the first thing that we're going to do is set the denominator not equal to 0. Our denominator is 6x minus 7. I set that not equal to 0 and I solve for x, which means that x cannot equal 7/6. Why can x not equal 7/6? Because it would make the function undefined. So let me graph this and see what this would look like on a basic number line. We would have this 7/6 not included, but we could have all numbers to the left and all numbers to the right of that 7/6, which means that the domain would include all numbers except for that 7/6. So representing this using interval notation, the domain would go from -infinity to that 7/6 union 7/6 to +infinity. To represent our domain using set notation, we would say the domain is curly brace x such that x cannot equal 7/6. And to represent your domain using inequality notation, the domain could be either less than 7/6, or you can have x being greater than 7/6, not including 7/6. So let's take a look at our next example. For this example, we have been given our rational function h of x, which is equal to 1 over x minus 3 plus 3. For part A, for which values of x is the function undefined, would mean that we are going to set the denominator equal to 0. What is your denominator? Your denominator is x minus 3, which means x equals 3 would make this function undefined. So if I input 3 for x, I would have a denominator that is equal to 0, which we do not like. Part B, we want to find the domain of the function expressing our answer using interval notation. So to find the domain, we set the denominator not equal to 0. And our denominator cannot equal 3. Why can it not equal 3? Because it would make the function undefined. So what are all possible x values that I can have? I could have all numbers to the left and to the right of 3. So using interval notation, this would be negative infinity to 3 union 3 to positive infinity. Part C wants us to find the zeros. So the zeros means the x-intercepts. To find the x-intercept, we're going to remember what that means. That means we have a point on the x-axis, which would mean some number comma 0. So where are we going to replace 0 in our function? We're going to replace y with 0. So I'm replacing my y with 0 and I'm going to solve for x. So let's minus 3 on both sides. We will cross multiply. We'll distribute and solve for x, which means that our x-intercept is the point 8/3, 0. Eight-thirds is roughly 2.7. I normally like having a decimal value, especially because we're going to eventually need to put this on a graph. Part D wants us to find the y-intercept of this function. So to find the y-intercept, we are dealing with a point on the y-axis, which means it's going to be 0, a number. So in this case, we are replacing our x value with 0. And we're going to solve for y, or in this case, h of x. So our y-intercept turned out to be the same value as the x-intercept. Does not always. We have the y-intercept as a point 0, 8/3. So roughly the point 0, 2.7. All right, part E. Using the information found above, we want to clearly label the intercept on the graph, which means the x and the y-intercept, and we want to use a limit notation to represent the domain of this function. So we do have the x and y-intercept already. I am just going to label those points on my graph. The y-intercept here, roughly the point 0, 8/3, or 0, 2.7. The x-intercept is the point on the x-axis, which is right here. That point is 8/3, 0, or 2.7, 0. So part A, I've labeled my x and y-intercept. Part I, we're going to use limit notation. So how do we use limit notation? We are going to determine what was it that we did not want. So let's scroll back up. We did not want an x value of 3. So let me go back to the graph. 3 is roughly somewhere here, very close to that x-intercept. So what we're going to see and determine is what happens to the left of 3 and what happens to the right of 3. looking at the function itself. So using limit notation to represent the domain, we're going to say the domain is the limit as x approaches 3 from the left of our function h of x. So as I approach this 3 from the left, my function goes down to negative infinity. We're going to see what happens as we approach that same x value, but this time from the right side. So as I approach that x value of positive 3, my function heads towards positive infinity. And this would be the domain of this function using limit notation. And that is all for domain and intercepts of rational functions.